The title of this article is PMT theory. It stands for photon mass theory. We can make a photon mass hypothesis, considering that all other particles carry some mass, except maybe the hypothetical gluon, particle gluon, and even we are not sure about it. The neutrino particle also was supposed to have zero mass, but after the discovery of neutrino oscillations, in the 90s, this has been ruled out. So one can say the photon is massless, period, and nothing happened, you can go home. Or it could carry some mass after all. And as you will see, this hypothesis leads to a lot of prediction and potential it has been said that the photon particle carries energy and momentum. That's true, but no mass, and no mass at all. And as a consequence, it is a consequence of special relativity theory. How can it be? This is like putting the cart before the horse. There are no theory in physics that make laws for the universe. Nature doesn't care about our theory. Instead, laws in the universe make or unmake our theories. That's true. So theories must fit the data, not the other way around. All right. Yeah. Yeah, there are two essential features in space. One is well known, the cosmic microwave background radiation, or CMB for short. A few words about this radiation pervading all space, which has been discovered in the 60s. It was found to have a thermal radiation spectrum in the microwave range of wavelengths, and it follows very closely to the Planck's blackbody spectrum. This is a theory about the spectrum of this particular thing, entity. This is a blackbody. So it is called a blackbody. It has been said that it is the most precisely measured spectrum in nature. It is a perfectly black body. It is isotropic with a faint and very smooth thermal glow with temperature variation of 1 part in 100,000, which is quite irrelevant and insignificant. It is still viewed as a fossil radiation that happened some 800,000 years after the Big Bang, during the time of what has been called the recombination period. And finally, it is considered as a landmark evidence for the Big Bang theory. there are two main features with the cosmic microwave background radiation. The peak frequency in intensity of the spectrum is around 160 gigahertz, with a wavelength of nearly 2 millimeters. We deal with that feature later on. The temperature of space has been determined to be 2.7 Kelvin above the absolute zero by observation with balloons, and in the 90s by dedicated satellites like Kobe or Planck satellites. And there are more for them. It has been refined to 2.72548 Kelvin by comparison with the blackbody radiation curve. As I said, it is a true blackbody. So you can make a comparison with the curve of the blackbody, and this blackbody, the temperature, you can determine the temperature very precisely. We have to know that this temperature has been measured in our galactic neighborhood and not elsewhere. It will be the sole parameter on which this theory has been developed. Another feature of space is the photon gas. It has been much less investigated. By definition, identical particles in a volume form a gas. This is the definition of a gas, after all. There is a photon gas filling all space with well-defined features. A smooth gas at very low pressure, absence of interaction between particles because there is no charge, and perfectly elastic collision. Also, it is stable and everlasting. Photons are not created nor destroyed. Now, the idea is that the whole 19th century of kinetic theory can be, this theory of gas has been developed in the 19th century, and it can be applied to atoms. It has been applied to atoms and molecules, and it could be applied to photons, despite the quite different size. About 1 million times smaller than for photons than for atoms. We jump from nanometers to femtometer in size. The question is, does the kinetic theory still work at that very small scale? Let's find out. Next slide. Again, I cannot move the slides. Can you move the slide number 3, please? Can you do? 3? Thank you. So we apply the old kinetic theory of gases to the photon particle. There is a paucity of information related to the photon particle about the number of degrees of freedom a photon can possess. QED, the quantum electrodynamics theory, says there are 2 degrees of freedom. It says there is 2 degrees of freedom only, but it should be much more, considering the photon apparently follow a helical path inside a light ray. This has been verified by microwave waveguides. We can try to make a count where 6 degrees of freedom could be the right number, not 2. It is quite important to know the number of degrees of freedom, and like that we can determine the mass of the photon. So we should have 3 degrees of freedom in translational motion, 1 degree of freedom for the intrinsic spin angular momentum, and 2 degrees of freedom for left and right polarization. They are called helicities. We can then apply the theorem of equipartition of energy, which gives the mean kinetic energy according to the number of degrees of freedom, when the internal kinetic energy of the particle is equally shared between all the accessible mode of motion. This is a complete theory. This equal to mc square. Energy is mc square. So mc square is equal to 3 kT, and K is the Boltzmann constant and T is the absolute temperature. So we get directly the mass of the photon particle. It is to be, I call it M. M equal 1.25 10 minus 39 kilograms. It is in a SI unit, and it is a very small mass. Besides, it has been demonstrated in the article that speed of light and speed of sound bear the same equation, and those speeds depend on the square root of the absolute temperature. So you can imagine that the temperature of space is not constant throughout the universe. So the speed of light shouldn't be constant either. We can now then go to the de Broglie wavelength associated with to the photon, because we know the mass now, and we can apply the de Broglie wavelength. Physicist Louis de Broglie, with de Broglie in French, has a great insight exactly 100 years ago. He said that all massive particles in an ideal gas in thermal equilibrium at a specific temperature have an associated wave with a wavelength called lambda. Lambda equals h over p. H is a Planck constant and p is a momentum, or mc in this case. So you can see there is m here. All conditions are met for a photon gas. It can be applied to massive photons. So we can calculate that frequency, and we find a frequency of 170.37 gigahertz. This is a quite interesting result. This is the mean frequency of the CMB radiation. On the other hand, the peak frequency was found to be 160.23 gigahertz. This has been, as I said before, measured by dedicated satellites. So you see those two close frequency. One is the peak, and one is the average frequency, or the mean frequency. There is a very strong correspondence between satellite data and the photon gas derived frequency, as we did. Is that radiation thermal? That's a good question. Is that radiation the thermal relic that happened 800,000 years after the Big Bang? Which is quite impossible. The waving would have disappeared a long time ago. Instead, it is continually generated by the gas of photon pervading all space at the right frequency. This is the origin of the CMB radiation and nothing else. What are the outcomes? Photon mass and CMB radiation permit to determine. One is a fundamental constant h, the Planck constant, and c, the speed of light, originates from the cosmic microwave background radiation, CMB. They both can be directly calculated from it. So the question is now, are C and H universal fundamental constants? They shouldn't be. It has been found that temperature in space is not constant throughout the universe. Some telescopes have measured very low temperature in space and also much higher temperature in space, much higher than 2.7 K. So the H and C constant shouldn't be universal. As I said, the speed of light is not constant either. See, with the equation, the first equation depends on the square root of absolute temperature. So we can give a much better definition of Planck constant, H. if you open a textbook, you will see that it is defined as the amount of energy that a photon can carry according to the frequency of the associated wave in which it travels. As you can notice, by this definition, it makes little sense. Now it can be interpreted with this theory as it results on the ratio between the quantum of photon energy and the mean frequency of the CMB radiation spectrum, or 3kT over F. So we know K, the Boltzmann constant, we know F, the frequency, and T, the temperature. So it is easy to determine the value of H. There is a little more complicated equation to calculate, to determine the speed of light directly from the CMB. There are also other features which are very interesting we can to investigate. I'm talking about the dynamic viscosity of the gas, because all the gases have a certain viscosity. The mean free path between collision between two photons in space, that makes a mean free path, and also the size of the photon. All this can be determined thanks by knowing the mass of the photon. We can also determine the very maximum frequency of a gamma ray. So the calculations they give mu equals 0.434 Pascal second. This is the unit of viscosity. L is the mean free path, is over 1 million light years. Maybe you know the Milky Way diameter is around 100,000 light years. So it is about 10 times more. And we can also determine the gamma ray frequency, maximum gamma ray frequency of 1.24 10 to the 10 to the power 24 hertz. This is the higher frequency from the electromagnetic, for the electromagnetic spectrum. We can interpret that as follows. Because of a very large mean free path, over 1 million light years, the blurring of very distant galaxy is minimal. And she has been checked again with a new space telescope. Looking at very distant galaxies, they are blurred, but not too much. However, they are very distant. Another feature is that the photon gas is very viscous. It is close to unity, like heavy oil. normal gases are in the range of 10 minus 6 to 10 minus 4 Pascal second. And the photon gas is close to unity. This high viscosity causes a strong dragging effect of the photon gas around evenly bodies in the sky, like the Earth. And that explains also several experiments like the Michelson and Morley experiment, the famous Michelson and Morley experiment. They can be adequately described with that tracking effect. Another thing, we get observation like the starlight aberration can also receive proper treatment with that. Another observation also is a picture of spiral galaxy, which displays a filamentary aspect. This is the evidence of the viscous photon gas present in that system. Okay, let's go to slide 5, please. Last slide. J'ai sauté le slide. Oh shit. Okay. Hello. Can you move it? Hello. Okay, 5 slides. And because the next one, please. There are consequences with that theory. With this theory of massive photons, we have gotten a harvest of unexpected results, which can be easily extended to more domains, especially in astrophysics and cosmology. We have to distinguish same photon with two modes. Those which are not disturbed by light rays, they can be called dark photons. They form the photon gas pervading space. Another category of photons are the photons participating in a light ray. That means all electromagnetic waves. They can be called active photons, and they are much more numerous than the dark photons. We can realize that in a small laser pointer, it delivers a billions of photons per second. They all have an invariant mass of 1.25 10 minus 39 kilo, either at rest or moving at any speed. Consequently, they make up the bulk of the universe. So the origin of dark matter and missing mass of galaxy is simply dark and active massive photons. This is a logical deduction like all the deduction we just have made with this article. We can now think about future research. we can investigate in the origin of fundamental constants. We did that already for two constants, h and c. There might be much more, and we can determine the other constant from the right theory. Another big question, can we make another model of the universe? We know that now, for time present, we have the lambda CDM, lambda cold dark matter model. This is the Big Bang, actually. It is today in jeopardy because of the discovery of large galaxies in deep space with a new space telescope, and also by the CMB origin that was found to be due to the photon gas. So it is time to put physics back on the right track by eliminating false concepts at the start, like the massless photon. We see that photon carries mass, contrary to what has been said. So as you can see, it is a mistake, but there are more mistakes like that. So this theory of massive photon has the capability to orient research in the right direction, where potential discoveries can be made in very diverse domains. We now know where to orient research. So finally, it is the right time to consider a new model of the universe. Thank you for your attention.